Good morning. Today's lesson is on solving exponential and logarithmic equations. What we want to notice first in the steps is that we have very distinctive steps here, 3 steps for solving exponential, 3 steps for solving logarithmic. And the nice thing is, if we kind of focus on the words themselves, it says that we want to isolate the exponential expression or isolate the log expression as our first step. So there's a lot of similarity there. You'll notice that I underlined it in purple. Then we're going to rewrite the equation. There's our verb. And over here we're going to rewrite the equation. So the difference being, if you're in exponential, you rewrite it in log. And if you're in a logarithmic equation, you rewrite it in exponential. And last but not least, in terms of a color coding, we'll finish the solving process using our typical SAD map kind of stuff as needed be. Sorry, I'm not sure why things are being so weird with the focus this morning. So, it says to solve the following equations, check for extraneous solutions. Give exact and approximate answers, so we're going to want to make sure that we have our calculators and that we've read the directions about rounding to the nearest thousandth. And then there's a note here about a few of the examples that involve a little bit more algebra savviness, so you may want to save those until the end. So the first thing I want to notice is that I have an exponential equation right now. And so I certainly can go through these steps, and there's nothing wrong with that procedure, but one thing I might want to also be aware of is that this problem can be solved using our old technique. If I recognize that 27 is 3 to the third, which obviously is a known fact for us, then I can say that the equal bases implies equal exponents, and then I can finish solving this in our typical fashion. So as an exponential equation, I certainly can use those rules that we have seen previously. However, if I compare that to this example 2, you notice that the identical side on the left is there, but what has changed is what the right side equals. And so instead, what I want to notice is I won't be able to rewrite 29 as a power of 3. So I'm going to need to follow our 3 steps. So the first thing I want to notice is that my 3 to the x to the, say that again. 3 to the x minus 1 is already isolated, so the exponential portion is isolated. So there's nothing to do in step 1, so I kind of just used purple. And instead I'm going to go straight to rewriting. So rewriting means that I'm going to use a logarithm. Since this is a base 3 when it's in exponential form, I'll use a small 3 as my logarithm base. And then I always move the exponent to the other side, and next to the logarithm, the thing that I'm taking the logarithm of is the base. Now it's a good idea to put that in parentheses. Now next what we need to do, since we've rewritten the equation in log form, is to solve. So basically I'll add 1 to both sides. Now whether I put that plus 1 after the log base 3 of 29, or whether I put it in front is completely up to you. If I do put it at the end, though, it's one more reason why I'm going to require these parentheses around the log base 3 of 29. So then I'll put a box around that, because that is my exact answer. I'll label it so that we get used to seeing what's happening there. Alright. We're going to kind of revise and switch orange to red as that orange pen seems to be drying. Okay, so moving forward we'll make sure that anything that we're doing to finish the problem is in red. So that's our exact answer. Now we still need to figure out our approximate, and so we'll do a quick look at the calculator to see how that happens. Now depending on the calculator model that you have, the techniques are different. This is an 84, and what we want to notice is one of the options is to go to the math button on the lower left, and then I can go to, or mid left I should say, I can scroll down to choice A and make sure if I have that option, log base, and then I'll be able to type in the 3 and the 29 as I see them on my paper, add my 1, and then we'll round appropriately. So our approximated answer is 4.065 to the nearest thousandth. I'll use a approximation symbol, and I will also label it as my approximated answer. And then problem 2 is also done. However, there is an alternate method on the calculator for some of you. If you also want to check to see if you have an alpha window and see if you have that log base t option there as well. Either of those methods works to type in our problem. And the last way, for those who don't have an 84 plus, the way that works for everything is to use something called the change of base. So you would just use the normal log button here on the further down the calculator, and you would use log, and then you would type the argument, which is the 29, and then you would need to divide that by the log of 3. So basically you take the argument and the base, and you take the log of each one and you divide them. That also allows you to calculate the ultimate answer.